Greeting everyone. The case study that we will use is Deepwater Horizon accident. Therefore, this is the overview of the presentation, which consists of presenter background, the description of the accident, evaluation of hazards, existing hazard controls, the use of hazard controls, fault tree analysis, laws and regulations, and the recommendations. Before we start, I would like to introduce our team members, which is Nursyafira Binti Abdul Rahim with metric number 80809. The other member is Muhammad Adib Razin bin Muhammad Adnan with metric number 80185. Description of the accident. On the 20th April 2010, a catastrophic explosion occurred on the Deepwater Horizon oil rig in the Gulf of Mexico, about 41 miles off the coast of Louisiana. The accident was caused by the loss of well control, which led to an uncontrolled release of oil and gas. The explosion and subsequent fire tragically claimed the lives of 11 rig workers and resulted in an unprecedented oil spill, with estimates ranging from 4 million to over 30 million barrels of oil released into the Gulf. Evaluation of hazards. The accident highlighted several critical hazards, including well control hazards, blowout hazards, chemical hazards, and fire and explosion hazards. For well control hazards, the loss of well control was the primary cause of the Deepwater Horizon accident, leading to the uncontrolled release of an oil and gas from the well. Secondly, blowout hazards. The failure to properly manage the well pressure and prevent a blowout resulted in a catastrophic explosion and subsequent oil spill. Next is chemical hazards. The release of large quantities of crude oil into the marine environment posed significant risk to the marine life, coastal ecosystem, and the human health. Last but not least, fire and explosion hazards. The initial explosion on the rig resulted in fatalities and injuries, highlighting the risks associated with hydrocarbon fires and explosion. Available existing hazard controls. Firstly, well control procedure. Strict well control procedures such as maintaining appropriate mud weight, conducting regular pressure tests, and adhering to established well control practices are crucial in preventing blowouts. Next, blowout preventers, or known as BOP. BOPs are designed to seal the well and prevent uncontrolled releases in the event of the kick or loss of well control. However, in the Deepwater Horizon case, the BOP failed to function properly. Next, emergency response plans. Comprehensive emergency response plans should be in the place to mitigate the consequences of an oil spill, including measures of containment, cleanup, and environmental protection. Next is safety management system. Robust safety management systems, including risk assessments, incident reporting, and continuous improvement processes are essential for identifying and addressing potential hazards. Next is regulatory oversights. Government agencies like the Bureau of Safety and Environmental Enforcement (BSEE) and the Environment Protection Agency (EPA) have established regulations and guidelines to promote safety and environment protection in offshore operations. Last but not least, training and competency. Adequate training and competency assessment of personnel involved in oil and gas operations are crucial to ensure they can effectively identify and mitigate hazards. Deduce existing hazard controls. Based on the event and consequences of the Deepwater Horizon oil spill accident, it is evidence that the available hazard controls did not function well enough to minimize the hazard effectively. Firstly, well control procedure. The well control procedure and practices employed by the crew on the Deepwater Horizon rig were inadequate, as evidenced by the failure to recognize and respond effectively to the initial well control event, which ultimately led to the blowout. Next is blowout preventers, or BOPs. The Deepwater Horizon's BOP, which was supposed to be the last line of defense against an uncontrolled release of hydrocarbons, failed to function properly. Next is emergency response plans. While emergency response plans were in place, the sheer magnitude of the oil spill overwhelmed the initial response capabilities, resulting in delays and difficulties to containing and mitigating the environmental impact. Next is safety management systems. The incident investigation revealed deficiencies in the overall safety management system, including inadequate risk assessment, lack of effective communication, and a potential normalization of deviance regarding certain safety practices. Next is regulatory oversight. The regulatory oversight mechanisms in place at the time were insufficient to ensure that the operator, the BP, and the contractors involved adhere to industry best practices and maintain the highest safety standards. Last but not least, training and competency. The incident highlighted gaps in training and competency among personnel involved in the drilling operations, contributing to the failure to recognize and respond effectively to the well control event. To the next slide is fault tree analysis. This fault tree analysis illustrates the sequence of events and contributing factors that led to the blowout and explosion on the Deepwater Horizon. On the top event, which is Deepwater Horizon oil spill, was caused by blow-up preventer failure and cementing failure. Let's take a look at the blow-up preventer failure. The blow-up preventer failure was caused by battery depletion on control pods and deadman system failure. As for battery depletion on control pods, it was caused by deadlock debris in the control pods, while for deadman system failure, it was caused by design flaw in blow-up preventer. Let's take a look at the cementing failure. It was caused by the gas migration, in which might be happen from form cement stability failure or form cement channeling failure. I pass to the next slide to the next presenter.
Assalamualaikum, my name is Muhammad Adib Razin bin Muhammad Adnan. My ID number is 80185, and now we will discuss about the safety laws, regulation and compliance issue related to well control procedure. Let us start with the relevant safety laws or regulations. On the left side, we have the Bureaus of Safety and Environmental Enforcement (BSEE) regulation. These regulations are crucial as they first govern well control procedure. Second, set blowout preventer, which is the BOP specification. Establish personnel competency requirement. On the right side, we have the International Association of Drilling Contractor (IADC) standard, which, although not mandatory, represent industry best practice for safety drilling operation. These standards cover areas like BOP maintenance and testing protocol. Understanding these regulations and standards is vital for ensuring safety and preventing disasters. Next, let's look at the complex failures. The Deepwater Horizon investigation highlights several areas where BP may have failed adhere to BSEE's regulation, particularly regarding well control procedure. First, analysis of BP's compliance. The analysis revealed concerning pattern in BP's adherence to regulation. Second, inadequate oversight. There are significant weaknesses in BP's oversight of its contractors, leading to failures in implementing necessary safety measures. The third one is concern about IADC recommendation. BP may not have strictly followed IADC recommendation for BOP maintenance and testing protocols, which could have prevented the disaster. The last one is cutting corners. It appears that BP prioritized speed and cost efficiency over established well control procedures, leading to critical safety oversight. These compliance failures were significant contributors to the disaster, underscoring the importance of strict adherence to safety regulation. Now let us discuss the ethical lapse beyond compliance. First, lack of transparencies. There were serious concerns about the accuracy and transparency of information shared about the well's condition. Withholding or manipulating information can have catastrophic consequences. Second is profit over safety. Allegedly, BP prioritized cost-cutting measures over established safety protocols, raising significant ethical concern about their commitment to safety. The third one is duty of care ignored. Every organization involved has a duty of care to its employees and environment. By potentially neglecting well-controlled procedures and failing to ensure proper oversight, these companies fail to uphold their ethical responsibility. These ethical lapses highlight the importance of not just following regulation but also ensuring that safety and transparency are prioritized to prevent future disasters. For our final slide, let's go over some recommendations for improved safety management. The first area focus on strengthening procedures and engineering practice. This includes developing clear comprehensive standards for critical operations, reviewing and updating well-controlled procedures, and updating design practice to incorporate safety considerations such as negative pressure testing in casting design. The second area concentrates on enhancing competency and capability. This includes reassessing the role of the technical authority, which named TA, in well control to ensure adequate oversight and expertise. Implementing robust competency development programs to improve the skills and knowledge of personnel, and developing advanced well control training programs. So thank you for your time. I hope this presentation was informative for you. Thank you.